Welcome back. Java application landscape is very complex. There are a number of frameworks and there are a number of things that you can build using these frameworks. And added to this is the latest complexity around microservices, full stack and the cloud. That's the reason why we are typically asked a question. How can I become a microservices developer? How can I become a cloud developer? How can I become a full stack developer? How can I learn to build web applications? And that's the reason why we are creating these learning path videos to help you navigate this landscape and have a clear goal and a path on how you can reach this goal. Each of the learning path videos that we would be creating would contain a prerequisite. What should you know before you start the learning path? It will have an audience who all can be the right audience for that specific learning path. It will have a goal. What do you want to achieve by the end of the learning path? It will have a list of recommended frameworks, tools that you would need to learn. And also it will have the specifics of what you would need to learn about each framework and each tool that will be present. And also we will give you details on how you can learn it, what videos you can watch, what courses you can follow, and all that fun stuff. Are you excited to get started with the Learning Path 01? Let's get started right now. The Learning Path 01 is actually the simplest of all the learning paths we are going to create. This learning path would help you to build web applications, SOAP web services, and REST API with Spring, Spring Boot, and Hibernate. The idea behind this learning path is as a starting point for junior Java developers. If you don't really have any experience with developing applications with Java, then this is a right learning path for you to get the experience of developing something really concrete. The prerequisite for this specific learning path is that you should know Java programming. You should have some experience writing a number of Java programs. Now, to build web applications, to build SOAP web services, to build REST API, you don't just need the frameworks. You also need a couple of tools. One is your IDE. You might use Eclipse or IntelliJ, and the other one is a build tool, Maven or Gradle. To be a great developer, you should also learn to write great unit tests. Now, let's dive in each one of these frameworks and let's look at what you would want to learn about each one of them. Let's start with the Spring framework. Why should you learn Spring framework and what are the things that you'd want to learn about Spring framework? Now, why should you learn Spring framework? How do we build applications typically? Typically, whenever we build applications, we build them into multiple layers. So you have a web layer, you have a business layer, you have a data layer. So this is how we typically build applications, whether it's a full stack application, whether it's a API, whether it's a web application. This is the architecture that we typically use. Before the emergence of Spring framework, when I have an application like this, the only way to test that application was to deploy the complete application. Let's say I create a var from this application. I need to deploy the var to Tomcat and then I can test everything. Why? Because these layers are tightly coupled with each other. The web layer is tightly coupled with the business layer. The business layer is tightly coupled with the data layer. So it was very difficult to do any kind of unit testing before the emergence of Spring framework. Spring framework made all these loosely coupled. I can write a test for a class in the web layer by stubbing out or by using a mock for the data it would get from the business layer. So it was possible to write specific unit tests and test specific chunks of code. Spring brought in this concept of loose coupling which revolutionized the way we build Java applications. And the other important thing about Spring Framework is the modularity of the Spring Framework. The great thing is it's not built as a monolith. It is built in a very, very modular way. So you had a number of components, Spring Core, Spring JDBC, Spring AOP. So you can use any of the components and not use the other components. That was one of the main flexibilities that Spring provided. So if I only want to use a specific JDBC component in a specific project, I can just take the JDBC component and not worry about all the other concepts that Spring brings in. And the other important thing about Spring was the simplicity it brought in. For example, if you talk about EJBs, which were actually ruling the roost at the time when Spring Framework started coming in, it was very, very complex. If you'd had to do any transaction management or implement anything with EJB1 or EJB2, it was very, very tough. And Spring made it really, really simple. With simple annotations, with simple XML configuration, we were able to do complex things like transaction management. So these are the reasons why you should learn Spring. Spring is one of the top frameworks in the Java world today, and I'm sure it's being used in more than 70 to 80% of the Java projects today. Now, what are the things that you would need to learn about Spring? What are the concepts that are important that you would want to learn about Spring Framework? The most important concept of Spring Framework is dependency injection, or it's also called inversion of control. How does Spring provide this dependency injection framework? It's through something called Bean Factory and also through something called application context. So these are the things that you need to understand when it comes to dependency injection with the Spring Framework. You need to also understand the different kinds of dependency injection. There is constructor injection, there is setter injection, and also there is something called field injection. You need to understand all the types of dependency injection and choose the right one for your specific context. The other important thing that you need to understand about Spring Framework are the different Spring annotations. There are a number of annotations like component, repository, there are at service, a wide variety of annotations to define a Spring component or a Spring bean. And if you would want to find all the beans in a specific package, you need to define something called a component scan. So with Spring, you need to learn what is a component and what is a component scan. The other important concepts that you need to learn about Spring Framework are something called CDI, context and dependency injection. After the Spring Framework got successful, there was widespread use of the Spring Framework. The CDI was introduced as a Java EE standard. So CDI is a Java EE standard which defines the different annotations and all that stuff around context and dependency injection. And Spring is actually an implementation of the CDI as well. So you need to understand what is CDI and why is it important. The other important thing that you need to learn about Spring is aspect-oriented programming. When we develop things in app layers, there are certain things which are common to all these layers. For example, logging, authentication, authorization, these might be needed by all the layers, and things like that can be implemented using aspect-oriented programming. So you would need to learn Spring AOP. So at a high level, the important things that you need to learn about Spring are related to the dependency injection. You need to learn what is dependency injection, you need to understand what is Bean Factory, application context, you need to understand annotations, component scans, and also you need to understand the two different ways of configuring Spring context. You can use an XML as well as Java. So the preferred approach today is the Java approach. Typically today, most of the projects use Java based annotations to define components, to define component scan and all that stuff. But if you go a couple of years back, XML was the popular option. So you were defining the Spring beans and auto-varying and all that stuff in a XML file. There you go. Those are some of the important things that you would need to learn about Spring. Now that we learned about the Spring framework, let's now jump into the Spring Boot framework. Spring Boot is one of the most important frameworks that evolved in the last few years. Today, whenever people say microservices in the Java world, it kind of relates to Spring Boot. It became so popular. Now, why did Spring Boot become popular? Thing is, Spring and Spring MVC frameworks were really awesome. However, you had to write thousands of lines of XML to configure something, or thousands of lines of Java code to configure a lot of things. Configure a database, configure a dispatcher servlet, configure a data source, and all that stuff were very tough to configure. And this meant that it used to take a long time, like 15 days, 20 days, to get started with a project, to create a new project, set up the layers, all that stuff. It used to take around 15 days. And this is without considering the non-functional requirements like application configuration, monitoring, and all that stuff. So the setup of a microservice used to take a long time before the emergence of Spring Boot framework. And that's the reason why Spring Boot framework became popular. It made the setup a very easy thing. Now, what are the things you need to learn about Spring Boot? What are the important concepts? The most important concept that you need to learn about Spring Boot is something called auto configuration. What is auto configuration? Let's say you want to develop a web application. All that you need to do is to add Spring MVC dependency into your class path. Spring Boot would automatically configure a dispatcher servlet and it would redirect all the URLs to that. So that's auto configuration. Let's say you'd want to use a database, you want to connect to a database. All that you need to do is add a JPA or a Hibernate jar into the class path, and Spring Boot would auto configure a data source for you. If you add an in-memory database, it would automatically configure a data source pointing to the in-memory database. So all this is the magic of auto configuration. Because of auto configuration, the amount of initial configuration that you need to do goes down drastically. The other important features that Spring Boot brings in are faster integration of projects. So if I want to integrate a new project, integrate a new framework into my project, Spring Boot makes it very easy. How does Spring Boot make it very easy? Through something called Spring Boot starter projects. So these starter projects make it very easy to add new features to your projects. If I want to develop a web application or a REST API, all that I need to do is use a starter called web, Spring Boot starter web. If I want to develop a web service, a SOAP-based web service, all that I need to do is to add a starter called Spring Boot starter web service. If I would want to add AOP features, I would need to add Spring Boot starter AOP. If I want to write unit tests, I would need to add Spring Boot starter test. So there are a variety of starter projects, including security. You have a starter data JPA to get started with JPA in your project. So all these starters make it very easy to get started with adding a new framework to your project. The other features which are present in Spring Boot are typically what are considered the non-functional features. So what are these non-functional features? Whenever we talk about an application, it will be deployed to multiple environments, right? You will have a dev environment, a QA environment, a stage environment, a production environment. So whenever you deploy code, it would need to go through all these cycles, and the database you would want to connect to in dev might be different from the database you want to connect to in prod. So you need to store all that configuration information in your property files. Spring Boot makes it very easy to have application configuration through something called profiles. So you can create separate profiles for dev, QA, stage, and production, and you can store the configuration for those environments in those profile files. It makes it very easy to do environment configuration. The other important thing that Spring Boot brings in is simplified deployment. How does it simplify the deployment process? Typically, before the emergence of Spring Boot, the most popular way of deploying web applications was to use WAR files. So if I would want to deploy a WAR file, what do I want? Tomcat. If I would want, or actually it can be Tomcat or any other app server. So it can be WebSphere, WebLogic, whatever you'd want. So Tomcat. To run Tomcat, what do you want? You'd want Java. To run Java, what do you want? There should be a operating system and also the hardware or the machine that you'd want. So to install a var file, there are a lot of things that you would need to do. And with Spring Boot, it brings in a concept called embedded servers. What is an embedded server? Example of an embedded server is Tomcat. So what happens is the Tomcat gets embedded into the jar file. So whatever is the output of the project, when you build a project, you get a jar file, and the jar file already contains the Tomcat inbuilt. And that's the reason why with Spring Boot, if you are building a jar file, you don't really need to install Tomcat. You can directly have a jar file and directly run it wherever Java is installed. So all that you need to run your application is Java. So the simplified deployment is very, very important benefit of Spring Boot. I've worked with a number of applications, number of microservices serving millions of requests which are built as jar files. A lot of people think var files are much more stable than jar. Actually, jar files can be as stable as var files, and that's why Josh Long says make jar, not var. Now, the other important things that Spring Boot brings in is monitoring. How does it bring in monitoring? You can add in something called Spring Boot Actuator. So Actuator helps us in adding monitoring features around our applications. The other thing Spring Boot also helps us to do is to make your development faster by something called developer tools. One of the things that slows developers down a lot is whenever you want to make a change, you need to restart the server. So make a change, stop the server, start the again. Instead of that, if you add developer tools, Spring Boot developer tools into your project, the restart happens automatically. Whenever you make a change and save the file, the restart happens immediately and the change will be visible for you. So if you look at Spring Boot, it really brings in a lot of efficiencies into the Java world. And that's the reason why Spring Boot is the #1 framework, and that's the reason why you should definitely learn Spring Boot in today's world. So the important things that you need to learn about Spring Boot are auto configuration, starter projects, and all the non-functional features that Spring Boot brings in. Now that we talked about Spring Boot, let's get into the world of databases. JPA is one of the most important evolutions in the last few years as far as connecting to a database from a Java application is concerned. Let's see the journey to JPA and what you have to learn in databases and also all the frameworks that Java provides to connect to databases. Let's get started with the basic things around databases. So whenever we talk about a database contains tables. So you need to understand what tables are, what columns are, how data is stored and all that stuff. You need to understand how to write SQL queries around your databases. So that's the basics, right? These are like not related to Java at all. You need to understand table, design and SQL queries. So those are things you would want to learn. The other things that you would want to learn when you would want to build a Java application talking to a database. So what does a Java application contain? A Java application typically contains class files. So you have let's say a course.java file, and in the database, let's say I have a course table. What do we want to do when we do develop an application? We would want to get the data from the table inside the database. So from this table, we would want to get the data and we would store it into an object of this course.java file, right? That's what we would want to do typically whenever we do anything in our Java talking with a database. And now, how do we do that? The most basic option to do that is something called JDBC. With JDBC, you can write a query. So you can write a query, select star from course where so and so condition, and it would return something called a result set back. You can take the result set and you can write code to take each value, each element from the result set and map it to the value inside the course object. So this is JDBC. The thing about JDBC is to do a simple query. Let's say I have 5 fields in course and I would want to take the data from a course row and put it into here. This simple query would need about 25 lines of code. So 25 lines of code to write a simple query, get the data and populate the bean. And it's a lot of code, especially there were like a lot of checked exceptions, and writing this exception handling code was very like monotonous. You just write the same thing again and again and again. And that's where Spring JDBC came in. So with Spring JDBC, the advantage was you did not need to write the checked exception code, and it also made mapping a result set to the bean easier. So with Spring JDBC, the same thing, you can do it with around, let's say, 5 lines of code. The next evolution was a framework called Hibernate. Hibernate made it even more easier. All that you need to do is give me a query and give me which object you need to pass, which bean you would want to create. So which class you would want to create the bean for. So you just need to say query and course.class. It would execute the query and it would return an object of this course.class. So it made it very easy for you to do this stuff. So most of the time you just configure a few things in XML and you would write 1 line of code and Hibernate would give you the result set back. The next evolutions which happened are JPA, Java Persistence API. Actually, the evolution which happened was Hibernate. So Hibernate brought in a new concept. What happened was these queries that we wrote became really complex. I was working with thousands of I was working with applications which had thousands of queries, and some of these queries were like 1,000 lines of query, and it became unmaintainable after a point in time. All the business logic was not in the business layer but was in the queries, and that's the reason why, that's the time period where Hibernate started becoming more popular, where Hibernate brought in a concept where instead of writing a query, so instead of writing a query to get the result from the course to course.java, what Hibernate does is it would add annotations on course.java to map it to a database table. So in course.java, you will say this course entity. So this course entity maps to a course table. This column maps to this column. So you add something called mappings, entity mapping, and you'll add something called relationships. So you'll define what are the relationships between different entities. One course can have multiple students. A student can have one passport. So all these are like a student can have one passport is a one-to-one relationship. A course can have multiple students is a one-to, actually it's a many-to-many relationship because a student can take many courses and a course can have multiple students as well. A course can have multiple reviews. That's an example of one-to-many because a review can only be associated with one course. So you define entities, map them to tables. You'll define inside the entities, you'll define columns and map them to table columns. And you'll also define the relationships between entities. You'll say one-to-many, many-to-many, many-to-one, and all that fun stuff. Once you do these mappings, what Hibernate would do is it would generate the queries for you. If you want to do an update, if you want to do a insert, if you want to get the data, all that you need to do is get the right entities and save them. You don't really need to write queries. All the queries are internally generated by the Hibernate framework. So how does the JPA architecture look? You have your classes and you use JPA magic. So you use JPA magic, and what do we do with the JPA magic? You would map these classes to the tables. So you will map it to the database tables. These classes which are used to map things are called entities. So these are entities and these are mapped using JPA magic to the tables. And Hibernate, once you map them, Hibernate would generate the queries for you automatically. Now, what are the other things that you would want to learn about Hibernate? The other important things that you would want to learn about Hibernate is the concept of entity manager. An entity manager manages the entities. So if you want to save something, delete something, all that is done through the entity manager. You'd want to manage transactions. Transactions are very important when it comes to database. Let's say I have account A and you are transferring amount from account A to B. The initial amount in A, let's say, is 1000 and in B is, let's say, 5000. And I would want to transfer 100 rupees from A to B. One of the ways of doing that is, let's say, let's do it in step 1, step 2. So step 1 is actually to reduce the amount in A. So at the end of step 1, so this is 900 and this is 5000, and after that is to reduce the amount, add the amount to B, right? So this is how we typically do, right? So you would first deduct the amount from A and then add it to B. Now let's say at this particular point in time when it was doing step 2, the transaction failed. Can we leave it in this specific state? Nope, right? 100 rupees has disappeared and that's not good, right? So that's an inconsistent state. What we would want to do is we would want to do the whole thing as a single transaction. If this fails, then everything that happened before has to be rolled back and we have to go back to the previous state. If it fails, we would want to go back to this state, and that is what is called transaction management. And with JPA, with anything to do with the databases, you have to do transaction management very, very well. So there are a lot of things that you would want to learn about transactions. The other things that you would want to do is few queries. Hibernate comes in to eliminate the need for writing queries, but there are certain situations where you have to write queries, and in those situations you would go for something called criteria queries or JPQL. Criteria queries enable you to actually write Java code to generate the queries. So you can actually write Java code and create queries. In JPQL, you'd be able to write something similar to SQL but using the entities. So instead of using the tables, in SQL we will use the tables, but in JPQL we will use the entities. We'll use the classes to write the queries. So these are the two possibilities. You would write queries when you would want to actually join, let's say, a lot of tables. You'd want to perform certain like highly performant activities. In those kind of situations, you'd go for JPQL or criteria query. The other things that you would want to learn are caching and also performance tuning. So you would want to generate queries which are really, really efficient. So you want to make sure that lazy loading and all that kind of stuff are efficiently performed. So you should be good at caching and performance. So at a high level, what we have looked until now are the important things that you would want to learn about JPA. You'd want to learn about classes, JPA magic. You'd want to learn about entity manager, transactions, criteria queries, caching, performance, and all that fun stuff. Now, in the evolution, we started with JDBC, we went to Spring JDBC, we went to Hibernate. After that, we said we went to Hibernate, and JPA is nothing but an interface for the Hibernate. So JPA is a Java EE standard. So once Hibernate became popular, Java EE said, okay, let's create a standard around it, and JPA was the standard they created, and Hibernate is actually now an implementation of JPA. So in projects, typically you would want to use JPA because you would want to be able to switch from Hibernate to any other ORM tool that you would want to use. But typically Hibernate is the thing which is used in 90% of the projects as the ORM tool, object relation mapping tool. Now, the evolution did not stop here. The next step in the evolution is Spring Data JPA. So what happened is after JPA, we saw that there was a lot of code that you need to write to play with the entity manager. So if you'd want to save something, you need to say entity manager.save. If you want to delete something, you need to say entity manager.remove or something of that kind. So that kind of a code became like standard. So if you'd want to play with 10 entities, you need to write 10 files which have very, very similar kind of code. And Spring Data JPA eliminates the need to write that piece of code as well. So if you want to really do operations like delete, insert, update with Spring Data JPA, all that you need to do is you need to create the entity and you need to extend a specific interface, and that's it. With 0 lines of code, with almost actually it's not 0, with about 2 to 3 lines of code, you'll be able to easily manage an entity. That's the evolution Spring Data JPA brings in. And the next evolution was Spring Data REST. So Spring Data REST was very, very important thing if you want to quickly prototype something. So you have Spring Data repositories and Spring Data REST can expose REST APIs around these repositories. All that you need to do is add a couple of annotations and that's it. You'll be able to offer REST APIs around your Spring Data JPA. So if you want to create a REST API around your JPA entities with Spring Data JPA and Data REST, you'll be able to do it with about 5 lines of code. So that's the complete evolution. JDBC, Spring JDBC, IBAT is Hibernate or JPA, Spring Data REST. So one of the important things that you need to understand is the entire evolution, and the amazing thing is this is not difficult. All that you need to do is learn in a methodical way, and you'll be able to get through all these stuff. So there you go. We started with databases, trying to understand what tables, SQL queries and all that stuff. Then we talked about the fact that to be able to get the data from the database, you need to have a Java class and write some JDBC code to get the data from the database and take the result set, take the results out of it and map it to an object. And after that, we looked at JPA in depth, where we talked about all the things that you would want to learn about JPA, and we looked at the other stuff in there as well. Now, let's look at how to build a web application. How can you learn to build a web application? One of the things that we always recommend in 28 minutes is don't learn a framework, learn how to build something using a framework. So we always recommend to learn building something, build a web application, build a full stack application, build a REST API using a framework. That's how you learn the framework in the best possible way. So always build something. If you look at the concepts which are involved in a web application, typically whenever you talk about a web application, what does it do? It would render to the browser, right? And this is called a request. So you type a URL in the browser, it sends a request out to the web application and you get a response back, right? So from the browser a request goes and you get a response back. So you send a URL, you get the HTML content back, and that's what is rendered in the browser. In Java world, the way you implement something like this is by using something called Java EE, and the most basic way of doing it is by using JSP servlets. So the JSP servlets allow you to build a web application which would be able to adhere to this request response cycle. And in the JSP servlet standard, the request is represented by HTTP request and the response is represented by HTTP response. So you can see already that the protocol which is used is HTTP, right? So anything on the internet works based on HTTP. So starting off, you need to understand JSP servlets. I would recommend you to actually build at least a simple application using JSP servlets so that you understand how JSP servlets work. The second thing you need to understand is the evolution of the web application architecture. So if you look at the pattern which is typically used to build web applications, it's MVC. So there are actually MVC evolved over a period of time. There was something called Model 1 architecture. So Model 1 architecture, Model 1. After that we evolved to Model 2, and after that we evolved to Model 2 modified. So this is also called MVC architecture, and this is called MVC modified architecture. This Model 1, in the Model 1, what used to happen is from the browser. So where does the request come from? From the browser, right? So from the browser, the request directly goes to JSPs. There might be n number of JSPs, right? So I can have 1 to n number of JSPs, and the JSP would do all that it needs to do to satisfy the request, and it would send a response back. So everything is based on the JSPs. So it was very, very, very tough because the JSPs had to do a lot of logic and maintainability was very, very difficult. So that's the reason why Model 1 architecture was quickly outdated and we went to the Model 2 MVC architecture, where we had a browser, and in between the browser and the JSP we had a servlet. So the request from browser go to the servlet, and from servlet it goes to the JSP, and there can be 1 to n servlets and 1 to m JSPs. So this ensures that you actually have something where you can actually talk to a database. Let's say you want to talk to a database, you can do that in the servlet, get the data, make the data ready, and you can make it available to the JSP, and the JSP can use the data and generate the view, and you can return it back to the browser. The other pattern which became famous with Spring MVC was the Model 2 MVC architecture, actually the Model 2 modified MVC architecture, which is from the browser you would actually send a request to something called a front controller. So instead of sending it to n number of requests, in this architecture what would happen is from the browser you might actually send the request to login servlet, to do servlet, logout servlet and all that stuff. But in the Model 2 modified architecture, you would always send the request to a front controller. All the requests will go to a front controller, and the front controller would then decide which controller or servlet to execute. It's just a change in terminology. So controller or servlet, whatever you want to call it, controller, it decides, okay, I would want to go to this controller, I would want to go to this servlet. What the controller or the servlet does is it would go to the database or wherever it needs to do, get the data, get the model available, and then what it does is it would actually redirect it to the JSP. So the front controller does the controlling of everything. It would send it to the controller. Once it gets the response back, it would actually send it to the view, generate the view and send the response back to the browser. This front controller in the Spring MVC world, or the Spring, like whenever we build web applications, whenever we build REST APIs with Spring MVC, what we are using in here is called a dispatcher servlet. So this is at a high level what happens with web applications. These are the most popular architectures, so you need to understand the MVC architecture. The third important thing that you need to understand when it comes to web applications is to do basic design of them, right? So how does a app page render on the browser? It uses HTML, it uses CSS, it uses JavaScript, and also you need to learn a framework on CSS called Bootstrap. It is one of the most famous frameworks to style your pages. So Bootstrap, B-O-T, strap, I think the spelling should be simple enough to find. Other than designing this, you need to also know how to do a layout, right? So whenever we talk about a web application, you have a menu, you have a header, you have a footer. So there's a header, there is a footer, there is a menu, and this is the content page. And whenever you click a button, do any action, the content page changes and the rest of the stuff remain as it is. So you'd want to be able to design pages in this format as well. So you'd want to be able to design the layout. The other thing you would want to be able to do is also do logout, login, basically the authentication and authorization features. Right? Typically in like the Spring world, we use Spring security to do these. And the last thing you would want to understand is how to manage session. So once a user logs in, you'd want to be able to identify the user. You want to know that the request is coming from a specific user, right? How do you identify it? In HTTP, the interesting thing is HTTP is stateless. So you cannot store anything in using the HTTP. So you should use, in the web app, you'd create sessions for each of the user. One of the ways actually, like in the response that we send back, we send a cookie, and the browser would take that session cookie and it would actually put it in the request and send it back to the web app, so that we can identify that specific user and use his session. So that's another thing that you would want to understand when you build web applications. So one of the interesting things is you can build web applications using JSP servlets. You can build web applications, I mean this is pure JSP servlets. You can build it using Spring MVC, which is the MVC framework, and you can use Spring Boot and Spring MVC. So a combination of these two to build web applications as well. What I would recommend you to do is actually try all these three options, because understanding JSP servlets, understanding Spring MVC, and understanding what Spring Boot brings in is very, very important. The awesome thing is we actually have 3 free videos which would help you to do this complete journey. We developed the same application with JSP servlets, Spring MVC and Spring Boot, so you can actually check out the free videos or even the courses which are present. We'll talk about the exact videos and courses a little later. Right now, we looked at the web application. How can you learn to build a web application? What are the frameworks? What are the architecture? And what are the different things that you need to understand when you build a web application? Let's now shift our attention to learning web services. How do we learn web services? That's what we would want to talk right now. So whenever we talk about web services, we need to understand why we need web services, right? Earlier, we talked about web applications. We said browser is the one which sends the request and we get a response back from a web application, right? This is how web applications work. Now, let's say this is a Java web application and I would want to talk to it from another application. Let's say I would want to talk to it from another Java application. Let's say there is some logic in here which I would want to reuse. How can I reuse it? One of the options is I can create a jar file. So I can create a jar file and I can share it with the other application and reuse the logic. But what would happen if the logic changes? I would need to again redistribute the jar, and the other application should again rebuild and deploy it. Now, let's say the other application is not Java application, but it's a Python application. From the Python application, can I make use of the jar? Oops, not possible, right? So from the Python application, I cannot make use of the jar, and that's where web services come into picture. With web services, you'd be able to support multiple kinds of applications. That's exactly the problem web services aim to solve. So let's say I have a web service. Let's say I have a Java application and a Python application. So both these applications will be able to talk to this web service and get the data it's offering. Let's say this web service is talking to a database or something, it offers a business logic. The Python application and the Java app can talk to this web service and get the data from there. So let's say this is a to-do app and these are two different to-do applications. Maybe this is a mobile app, this is something else. They want to talk to the web service to get the data. So all that is possible when you use web services. Now let's look at the basics of a web service. The most important thing about web service is built to support machine-to-machine interaction. So the interactions which are typically present are from an application to another application. That's what web services typically support. So these web services can be consumed from a web application, a full stack application, a mobile application, or an IoT application. Anywhere you want to be able to consume this web service. The second thing is it's interoperable. What do you mean by interoperable? It means that it is platform independent, it is language independent. I'll be able to talk to it from a Java application, a Python application, anywhere. There should not be any constraints on where I can use this web service from. The third important thing is web services involve a communication over network. If I take a jar file and make it part of my deployable unit, it's not a web service. It's only a web service when I make a call over HTTP, over queue, or some kind of a network. Only then it can be called a web service. Typically, whenever we talk about web services, there are a couple of things that you need to always decide. What is the format of the request? What is the format of the response? Is it JSON? Is it XML? What is the structure of the request? What is the structure of the response? What should be the elements which are present in there? So all those are some of the complexities that are typically present around web services. These things are defined by using something called a service definition. Service definition will say, okay, I'm going to use XML. This is the format. I'm going to have this structure for the request, this structure for the response. So that's what the service definition allows us to do. Now that we are introduced down about the web services, let's learn about what are the important things about SOAP web services. One of the interesting things is SOAP services came in at a time when service-oriented architecture was very popular. Service-oriented architecture, applications like, let's say there are a number of web services, web service 1, web service 2, web service 3, and there are applications that want to talk to these web services. So app 1, app 2, app 3, and so on and so forth. So the way they used to communicate is they would put a message on the ESB queue and the message would finally reach the web service and you would get a response back and the response would be taken in by the app 1. So this was the typical architecture, ESB based architectures at that particular point in time, and most of the times these were SOAP based services. SOAP stands for Simple Object Access Protocol. The thing about SOAP is it puts a rigid structure. You have to define something called a WSDL, Web Service Definition Language, and this WSDL defines something called a SOAP header, a SOAP body, and a SOAP fault. So you have to define these for your request and your response. What should be the request header, what should be the request body, what should be the response header, response body, and what should happen when there is an error that happens, when there is a fault that happens. So these are all the things that you need to define when you would want to start using a web service based on SOAP. The thing is, it was really complex because the frameworks to be able to do this were also very complex. So when I look at the frameworks which are typically used at that particular point in time, there were frameworks like Apache Axis, I think Apache CXF, those two were quite popular frameworks. Then there is JAX WS, which is Java API for XML, I think, and WS stands for Web Service. This defines a standard around how you can build your SOAP web services. The other framework which is popular is Spring Web Service. Spring Web Service uses a XSD based approach. You define an XML schema definition, and Spring WS would actually generate a WSDL for you automatically based on the request and the response XSDs. So these are some of the frameworks which were popular in building SOAP web services. The thing about SOAP web services are they are little complex because there is a lot of ceremony involved. You have to create a WSDL. Like executing SOAP requests is not easy because you have to actually have specific SOAP clients to be able to execute any request. So if a layman looks at the SOAP XML request, he'll not be able to really understand it at all, and like there is a lot of ceremony involved around SOAP. So that's the reason why SOAP fell by the wayside very quickly. So if you want to learn SOAP, the best way to learn is actually build a SOAP web service. I would recommend to use Spring Web Service because that's one of the most popular options. So you can build a couple of SOAP web services using Spring Web Service to learn SOAP. And you'd want to focus on understanding what's the SOAP header, SOAP body, SOAP fault. You want to understand what is the WSDL. You'd want to understand how to create an XSD, and you'd want to understand how to secure this by using WS Security. Let's now talk about how you can learn REST API. Before we talk about learning REST API, let's understand what REST API is all about. We know how the browser works, right? So on the browser, you send a request and the request goes to a web application, for example, right? So a web app, you send a request and you get a response back. The protocol which is typically used in this is HTTP. And when you actually type a URL in the browser, it sends something called a GET request. The interesting thing is HTTP also supports a wide variety of other requests. GET, PUT, POST, DELETE, and a variety of other stuff. So these are all the methods which are supported by HTTP. And when you build REST API, what you are doing is making use of the HTTP protocol. So REST API is all about making the best use of all the things which are present in HTTP. Making use of the resources, creating good resources, and using these methods to do actions on the resources. The format which is typically used with REST API is JSON. So JSON is much simpler format compared to XML. Like typically JSON's size is much smaller compared to XML. So JSON is the preferred format when it comes to REST API. But it's important to remember that REST API does not enforce any standard on what should be the format. So it can be JSON, it can be XML, whatever format you would want, you can use it to build REST API. The only constraint that REST API puts, the only constraint is that you have to use the best, you have to make the best use of HTTP protocol. Now, whenever we look at building a REST API, what are the features that you would want to build into a REST API? Let's quickly look at them. So you want to learn REST API, what are the features you would want to build? one of the important features is something called HATEOS, hypermedia as the engine of application state. This is actually like whenever you go to a web page, you do not just see the data. You can also play, like you can have links to play around with the data. You want to edit it, modify it, you want to delete it. You can do all that links. So HATEOS brings that to your REST API. So instead of just returning the data back, when you use HATEOS, you can actually return a few links back, which can help you to perform actions on the resource. The other important thing is documentation. REST API does not have a standard documentation format. So the service definition, there is no standard format. Right now in the last few years, OpenAPI, which is actually Swagger based, is becoming popular. So that's a popular documentation standard. You'd want to learn how to do security, how to build security around your REST API. There are approaches like JWT, JWT, JSON Web Token, which is very, very popular. A simpler approach is basic authentication, but it is not perfect. The other things that you can learn is how to version your REST API. There are multiple approaches, URL based approach, you have a content negotiation based approach, you also have a header based approach. So these are all the approaches that you can learn to do versioning, and also you'd want to do validation. So you don't want to accept any data without validation. So if a request is coming in, you want to validate it. So all that stuff you would want to learn. The other things that you would want to learn are best practices around REST API. One of the most important best practices is customer first. So whoever is consuming your API, think about them. Think about what are the resources they would want. Think about how they would consume the services and make it really, really easy for them. Serve them like the best possible documentation so that they don't have a lot of problems. If they don't have a problems, you should, it's a big win for you. The other thing is to understand something called a Richardson maturity model. So a lot of people say, I'm using REST APIs. I'm using REST in the best format possible. Richardson maturity model helps you to evaluate that. So you can say, I'm at level 0, I'm at level 1, I'm at level 2, I'm at level 3. Now, what is level 0, level 1, level 2, level 3? Level 0 is just use HTTP as transport. So instead of using like any other form of transport, you'd use HTTP. So if you actually take normal SOAP APIs, SOAP REST web services, and offer them over HTTP, they become a REST API as well. So they become REST API at maturity level 0. The next thing is to actually use proper resources. So the next thing is to think about your like the things that you are offering and create proper resources around it. So let's say if I'm building a course platform, I would have resources /courses /students and all that /reviews and all that fun stuff. The second level is to actually use HTTP verbs. So we already looked at HTTP verbs: get, put, post, delete. So if I want to delete a student, I would send a delete request to this specific URL. If I would want to add a new student, I would do a post to the URL. If I would want to get the details, then I would send a get request to /courses and will get all the courses for me. So the level 2 is to make the best use of HTTP verbs, and level 3 is HATEOS. So earlier we talked about adding links, not just giving the data back, but also adding links and specifying different actions that you can do with the resource. The last and the important standard is enterprise standardization, right? So you are building REST API, you'd want to use same standards across your enterprise. So which level you are at in the Richardson maturity model, which versioning you would use, how do you want to do security, how do you want to do documentation, how do you want to do validation. It's very, very important that you standardize that, and it might be awesome if you can actually build a framework around all that and use that in your enterprise. That would ensure that all the REST APIs that you build in your enterprise are all standardized. So you'll not have any variations in how you implement your REST API. Now let's look at the frameworks. So what are the frameworks that you have to learn to implement REST API? The most popular framework is Spring MVC or Spring REST, or whatever is provided by Spring Boot Starter Web. That's the framework. The other option is JAX WS, actually JAX RS Java API for XML for REST services. The other option is also to use one of the JAX-RS compliant frameworks. Like one of the popular implementations of JAX-RS is Jersey. You can use Jersey to build your REST API, or you can use any of the modern microservice frameworks, Quarkus or Micronaut. What I would recommend you to do is to start with Spring MVC and build a REST API. It's very, very important, as I said earlier, to build something. I mean, it's always the focus should be on building something, not just learning the framework, but building this REST API with all the features, making sure that you understand that perfectly. That's how you learn your REST API. So there you go. Those are the important things that are related to REST API. Last but not the least, the most important things to learn is to become an efficient developer. And to be an efficient developer, you need to know how to build your project. Your project might be having a number of Java files. How do you create a jar file from it? How do you create a var file for it? How do you run the unit tests? All that is part of your build. And the tools which are typically used are Maven and Gradle. You have to learn one of these build tools in depth. The other important thing that you have to learn is unit testing. Whenever we want to write any piece of code, you'd want to write unit tests for it. You'd want to immediately check if there is a problem with the code you are writing. Unit testing makes it very, very easy to check for problems. The amazing thing about unit tests is you can continuously run the unit test in a build and you'd be able to get the immediate feedback. So typically in projects you have something called continuous integration, where as soon as you commit some code, all the tests would run and it would tell you if something has failed. So unit test will help you to get immediate feedback in case of a failure. And typical frameworks which are used are JUnit for writing the basic unit tests. You can do mocks using Mockito. The other important framework in the unit testing space is something called Spring Unit. The thing is, whenever we talk about applications, you build them in multiple layers. You have a web layer, you have a business layer, you have a data layer. The thing with unit tests is you can write tests separately for a web layer, separately for a business layer, separately for a database layer, and also you can write integration tests combining all these stuff. With Spring Boot starter test, you get all the things you would need to write to be able to write individual tests for each of these layers and also integration tests for all the layers together. It would be amazing if you can actually learn all that stuff. The last but not the least thing whenever we talk about IDEs, whenever we talk about programming, is your IDE. You'd be spending more than 60% of your time on your IDE, and it's very, very important that you focus and learn your IDE very, very well. Whether it's Eclipse, whether it's IntelliJ, whether it's Visual Studio Code, spend some time and become an expert on the IDE. If there is one thing you would want to take out of this video, that's this. Remember that becoming efficient with your IDE will save you hours and hours of time in your career. Actually, days and days of time in your career when you put it all together. So become an expert at the IDE, become an expert at the build, and become an expert at unit testing. Now, until now, we looked at what you have to learn. What are the skills that you would want to learn? And we looked at each one of them in depth. You'll find a link to this learning path in the description of this specific video. So we are looking at whatever link which is present in here. This is learning path 01, and we would want to become a web app and an API developer. And we looked at all the recommended skills. Spring Boot, we would want to actually build web applications, SOAP web services, REST API using Spring Boot and JPA Hibernate. And we would want to also learn unit testing with JUnit, Mockito, and Spring Boot test. We also looked at the fact that the prerequisites are Java programming, and we have a recommended course path and a recommended preview courses. So all these are free videos of free courses. So all these are present in here. So this is the path we recommend you to follow to learn this learning path. So we would recommend you to actually start with the Spring Framework course. After that, we would recommend you to actually go to the Spring Boot course. These two courses are amazing courses. You can see that there are thousands of people who have done these courses as of now, and they have amazing ratings as well. And you can next go to a Master Java Web Services and RESTful API with Spring Boot course, which is an amazing course to learn to build SOAP Web Services and RESTful API. And after that, we would recommend you to go to the JPA and Hibernate course. And after that, you would want to go to the unit testing course, where we would actually discuss how to independently test each of the layers in a REST API, in a web application, and things like that. One of the important things is, for me, the most important courses in this path are this, and this. So Spring Boot, and Java Web Services are the most important parts of this code, where you would actually build the applications. The last two courses are ones where you would enhance your skills. So you would want to go in depth with Hibernate and JPA. You would want to explore Java unit testing in depth. So that's where you would go in and all that stuff. Now, there are also a set of free preview courses which are present in here. So Java Servlets and JSP is an amazing course which helps you to get started with Java Servlets and JSP. You can build a web application with that. Spring Frameworks in 10 steps also is a nice course to get started with Spring Framework, get a quick hang of it. Same is the case with Spring Boot for beginners in 10 steps. Spring MVC in 10 steps is also a nice video. JP and Hibernate in 10 steps is a course, it's a free course which enables you to get started quickly with JPA and Hibernate. And the other tutorials which are present in here are Eclipse, Maven, JUnit, and Mockito. These are essential. As I said earlier, learning your IDE is very, very important. Learning the build tool is very, very important, as well as learning the unit testing stuff. JUnit and Mockito is also very, very important. If you are done with this learning path, I would recommend you to check out the other learning paths which are present in here. We have 4 more learning paths as of now. We have microservices, a cloud learning path, a full stack learning path, and then AWS learning path. I hope you had an amazing time watching this learning path, and I hope I'll see you in another video very, very soon. One of the important things I would recommend you to do is always try and build applications. Frameworks are not important. It's important to build applications. It's important to build a web application, a REST API, a SOAP web service. That's where you learn the most. Trying to learn just the framework, all the concepts around a framework do not really help. It's building applications which really helps you become a very, very good developer. And do not forget to try and become an expert at the tools. So to learn your IDE, learn the build tool and all that stuff very, very well. I hope you have a nice learning time, and I'll see you in another 28 minutes video. I'm sure you had a wonderful time watching this video. A number of times I am asked this question: where do I go from here? What next? There are 4 amazing things that you can do to benefit from the great content that we are creating at in 28 minutes. A number of developers wonder how they can become a full stack developer, a cloud developer, a microservices developer, or a DevOps developer. We have amazing learning path videos to help you understand all these career paths and decide what you want to be. Number 2, this video is part of a series of video called Draw with Ranga, and you can actually download the free PDF containing all the amazing images which we have drawn during these series of videos by registering for a free course. Number 3, you can check out our 500 plus amazing videos that we have created over a period of last few years. These videos are organized into playlists to help you learn Spring, Spring Boot, full stack, microservices, and the cloud. Last but not the least is number 4, check out our course catalog. We have a wide range of courses to help you become an amazing developer. So what's stopping you? Go ahead and keep learning in 28 minutes. If you like this video, make sure that you like and also subscribe to this channel. Until I see you in another in 28 minutes video, here's bye from Ranga at in 28 minutes.